So my name is Michael. I'm with IBM. I work on SMB related stuff since like 2008. But Volker, in his introduction, right, he reminded me when I went to school and my dad had a small business. He was running a Novell file server. Serious? And the nice thing was on the 386 machine, you could run the Novell server in upper memory and still have a DOS box. Yeah. All right, that was like 93 or so.
Network ELS2, I think. That was
Yeah. Of course, the IPX and all, ArcNet and Token Ring. All right, but this is about SMB Multichannel and how we're using it in Storage Scale. So I'm not going to tell too much about Storage Scale for now. So SMB Multichannel is, you probably heard a lot about that. This technical community here was introduced in 2012 as a means to improve the network performance, right, for file servers. So it's meant to use multiple network interfaces or and network connections. So I'm separating the two, right, because there is the actual network interfaces and the TCP channels. So, and with the idea, okay, we have increased throughput and fault tolerance even, and it's meant to be auto-configuring. So, in order to take advantage of it, we need multiple network adapters or network adapters that support what Microsoft calls the receive-side scaling, and or adapters that are set up for network bond or NIC teaming, as is called in Windows world, and eventually RDMA. So there's this nice chart from Microsoft, which is still online on their webpage. It says, if I have a single session with SMB without multi-channel, then what can happen is that I overload basically the CPU serving the network adapter, kind of single-threaded. And we may end up with one CPU overloaded and other CPUs kind of idle. So there's the idea when we have multiple sessions, we have multiple TCP IP connections, and the reserve side scaling distributes the work to handle the connections to all the CPU cores. And therefore I can get better response times because the CPUs are all loaded, but a lot less loaded. And so overall throughput we can improve. So, but now we in Storage Scale, we have the GPFS file system, which is cluster file system. So we run clustered Samba. And this picture here kind of tries to show what this would look like, right? So we have something that is having three what we call the protocol nodes. So they run the Samba daemon. See the Samba daemon down here. And we can make it host a number of virtual IPs that we move between the nodes and that the clients will use to connect. So if you think there is one client, like the one left, and imagine there would be 3 connections in use by multi-channel, so you could think about each connection directing one of the virtual IPs. And the problem is kind of immediately visible, right? Because you see down there, there's kind of 2 active protocol nodes, and 1 node is offline. And we have 6 IP addresses and 3 nodes. So what will happen when I turn on the node? And so I turn on the second protocol node, becomes online, and redistribute my virtual IP addresses. And now one of the IP addresses that are used in this multi-channel set now moves to the other node. So that kind of scared us for a long time and said, okay, we would like to do multi-channel, but this is a problem. We don't really know how do we dynamically update the configuration when we add an IP or remove an IP. What do we do when these IPs are in use by a multi-channel? Will there be races between what the client sees and what the server sees, how the IPs are started and running? And as a complication, of course, we are not using CTDB to manage the IP addresses. We manage the IP addresses on our own. There's a kind of daemon shell framework that manages the IP addresses. So it has no idea of the Samba configuration and has no idea of the active multi-channel stuff. So therefore we said, oh, let's better not do that. But then how does it really look if you look a bit closer at our server node? Right, so there's again the SMB client. It connects via a link to the network or switches. And from there it connects to the protocol node. And what we usually have in our setups is we have a number of network interface ports in a bond. Right, so we have port 1 and 2 here bond together into a logical interface, and we run the virtual IP addresses on the logical interface. So we have high availability on the adapter already because we have a virtual adapter that will survive any one of the port 1, 2 failures. We have potentially aggregated bandwidth depending on the bonding mode. And of course, what's not seen visible here is because we have a cluster and we have connections to the other cluster nodes, there are quite a few more networks than the networks we run the virtual IP addresses on. So obviously you would not want to have a SMB client attempt to connect to the internal network of our cluster. So, in order to overcome that and not get into the business of testing out race conditions with IP failover, see if we have data consistency problems when IPs move, we simply decided, okay, now let's just use one IP. Right? So we looked at the SMB code that distributes that announces the IP addresses that are interfaces that are available. And we said, well, let's not exclude the interface that our client comes on, but just give that and none else. So we give out in the query interface, we give just one IP address back, one interface. And we allow the client to open multi-channel on that virtual IP. So therefore, we bypass all the problems that are related to kind of splitting where IPs move. And we can still do that. We can still allow the client to have multiple IP links, multiple interfaces, and come in using different IP addresses. Whereas on the server side, we stay with one connection, one IP address. And that all kind of works because we are in 2026 and interface speeds are no longer such a concern. If I look at a typical configuration of our protocol nodes, so these are kind of 4 snippets of LSPCI taken from recent customer cases to see what configurations do they have. So the first one, hope it's readable, right? So they have 8 network cards, network ports in it, right? And 2 of them are on a InfiniBand link, connecting 6 cards. They allow up to 200 gigabits, but it's InfiniBand, right? So it's kind of the cluster link between the nodes. And the most bottom ones in the first example are ConnectX-5 cards. They are used as Ethernet controller. So they give us 2 times 100 gigabits speed. Next example is, again, lots of network cards, but the ones used for the protocol section are 2 times 40 gigabits. And another example, 25 gigabits, and one more 25 gigabits. So this, of course, is all to this, right? So we can go to the Ethernet Alliance website and see the roadmap. Right in 2012, most had 10 gigabits as high-speed network, right? Evolving into what we now have, 400 gigabits, right? 400 gigabits is kind of standard on Mellanox CX7 cards. It's part of our storage box. So there's plenty of line speed, kind of removing some of the need to really combine even more lines for SMB. And so this is what it looks like if we reply to the query interface from the client. So you see it's basically empty. We just give back a single network interface, right, with a single IP address. And so does it work? Yeah, it does. So again, if you take kind of this sample, where you have a client with 2 network cards and a server with 1, so 2 IP addresses on the client, 1 IP address on the server. I can go to my Windows machine and run the get SMB Multichannel connection command. And I find, okay, it shows me 2 interfaces. So these are kind of the 2 blocks that you see here. You see it's the same server IP address, 101, ending 101. There it is, and there it is. And the client has 2 IP addresses, 201 and 202. And now when I initiate, and you can see there's a max channels definition, right? So by default, you will see 4 channels per RSS capable interface. We have 4 here in use 0 and 4 here in use 1. And we see client just accepts that we just give him this 1 IP address, this 1 interface, and still opens 2 times 4 channels. Right, so you see. Channels go up to 4 for both the interfaces. That's kind of neat. Right, so on our CNS nodes, that's the name of our protocol nodes. Right, we can see basically the multi-channel connection be established by just checking the network links, the netstart output SS here. We see 8 TCP connections. They stay up. SMB status doesn't give us any clue if it's multi-channel or not. Maybe that's an area for a future enhancement. All I need to do make a status let us stay active is just have the Explorer sit there, notify on map network drive. Right, and so something to look at, which is some of the performance numbers that we have taken. So you would think, okay, now I do multi-channel, now everything's happy. That is not the case. So if we just take one section here of this busy table and look at number of threads 4 and the I/O sizes that we use here in this IOR test, we can see if we compare the numbers here, right? So with 64 IO block size, we get from 1800 megabytes per second to 2000 megabytes per second. It's about as much as this Windows SMB client can do on this setup. So it's slightly better if you just look at those numbers. Right? So we can kind of assume, all right, with multi-channel and 4 threads working, I can get to this limit easier than when I do no multi-channel. But the result overall really is mixed, right? So you can see if I do small block sizes and 1 thread, there's practically no advantage for multi-channel. And on the other side, also for high numbers, right, we get into a saturation with no multi-channel, and so there's very little advantage for multi-channel. And I have a similar chart for writes, but it looks kind of worse even. Right? So there's no significant advantage for multi-channel, even in this good case where we have number of threads matching number of available channels. There's no advantage here, Volker.
What's the exact is it SMB client against Scale, or is it Windows against Scale, or what is it?
This is Windows 11, no, Windows Server 2019 against Scale.
Okay.
Right. So yeah, so we have multi-channel. There are some areas where we see some improvement. Having multi-channel and the option to correctly use the query interface command, right, is kind of our pathway into maybe a future with RDMA. We would see another entry here offering RDMA interface. But overall, it's not the big breakthrough we were expecting or hoping for. All right. Then, I guess closing words, basically the product, IBM Storage Scale IBM Storage Scale has a developer edition. It is non-charge downloadable. You need a IBM ID to download it. It's fully functional. You can build a 1,000-node cluster if you want. But it only allows you 12 terabytes of disk space. So except for the disk space limitation, it's fully functional. So you can test all the features embedded. Management of the SMB server, NFS server, replication, the performance. That's a link here. And here's my email address for any questions. Any questions right now? Please.
Do you need any special configuration? Thank you. Hello. Do you need any specific configuration for the Windows client to use the multiple interfaces as the client? Because on Linux, on CIFS, we don't do anything like that. So if you have 4 interfaces and then you connect to a multi-channel server, it will only use one interface to connect. So I was wondering if Windows does something different.
Well, it certainly checks for the RSS capability of the interface.
Yes.
But I mean, that same exists for Linux, right?
Yes, but I mean to make use of the interfaces.
Yeah, I mean, that is the tricky thing, right? It is a negotiation between the client and the server. So the client does ask the interface question, right? And if we give it something reasonable, then it will open the multi-channel connections.
Yeah.
Right? We don't control and we don't quite understand, right? What is the logic inside Windows that makes it open the multi-channel connections?
Okay. Yeah.
Right?
Okay. Yeah. I was wondering if there was any configuration to do that, because SIFS doesn't do that, and I was considering doing a patch to do that. Because if we have 4 interfaces and then a multi-channel using only one, that makes no sense from the client side to connect from a single interface to the other 4 on the server, for example. It makes, for me personally, it makes sense to connect all 4 to 4 interfaces on the server. Because when the client asks for multi-channel, it asks only for the server interfaces. It doesn't care about the client interfaces.
That's correct. Yeah.
Yeah.
And it will. And it
No,
is.
yeah, because on your that slide, the
Right. If you look at this response, so this is the response sent by the server back to the Windows client, right? That has the list of network interfaces that we can use for multi-channel.
yeah.
Right. It has only one entry. It's good enough.
No, I meant the next slide, I think. Yeah, that one. You list the other one. Yeah, this one. It lists two interfaces from the client.
Yes.
So it says that SMB is using those 2 interfaces.
Yes, and you can see the result here, right? This is the output of the get SMB multi-channel command on the Windows machine, right?
Okay.
And you can see that the Windows machine has client IP address 10.0.100.202 and 10.0.100.201.
Okay.
Right, while the server address is only the 101.
Okay.
Still, I mean, you would think, why would it do that? But it is okay for the client if the server announces that multi-channel capability exists and the interface is capable to do that.
Yeah.
And then everything else will be managed by the client. And the client, in this case, even though it has 2 interfaces, it knows the server has only 1 interface, it still makes 2 interfaces connect to the server.
Okay. Yeah, I was wondering, maybe this is some improvement we could do on SIF scale, because it currently doesn't do that. Okay. Thank you.
All right.
So we don't have to do the NIC teaming here on the client side?
No.
I mean, no.
No.
It automatically discovers that there are 2 interfaces and then uses
Yes.
it. Okay.
Just a comment on the SMB status output. If you use the -JSON output, you will see all the channels.
All right. Okay.
Is this only usable with the SMB shipped with IBM Spectrum Scale, or also with the standard SMB?
The patch is not upstream,
Okay.
but it's kind of trivial. And of course, we would give it out to our customers.
Okay, thank you.
Have you figured out what the bottleneck is, why you can't go any higher, performance-wise?
Not yet. We're still working on it.
Okay. Because, I mean, there must be some bottleneck. Is it client? Is it network? Is it SMBD? Is it GPFS? Is it whatever?
I think that the clients we've been using in this experiment were not very well chosen. They have many, I said it's Windows 2019, right? They have a lot of CPUs, but each of them is quite weak. And the adapters are kind of aged, so. All right. Then that's it. Thank you for having me.
Oh, wait, one more question.
All right.
Have you tried with more than 1 interfaces on the server side?
Yes. Yeah. I mean, by default, we have Bond there.
Okay. And does the performance numbers differ with one interface and more than one interface on the server side?
I can't tell you that.
Okay.
Yeah.
Okay, thank you.
I think we've been using a bond in active-passive mode, really, right? So that doesn't give you extra bandwidth. It just gives the high availability. Right.
Oh, one more question.
Yeah, if you could just go back to the slide that you were just showing. I was wondering, the server link speed, that value, is that kind of manually set? Or it's the result of the calculation? Okay. I was wondering whether this could have an impact on the client assumptions.
That's actually fast.
Yeah.
It's
Very.
-1, right? It's not really set. This example was taken on a virtual machine, so.
And the other thing, I just don't know it, but maybe there are also options to enable some more debugging on the Windows client side. Some event log information maybe that could hint to some misunderstandings or some reasons that would explain that speed. Did you have a chance to see if there's anything other than using the PowerShell commands for multi-channel connections on the Windows event log that would kind of give some hints?
Why it's so?
No.
It's just in the driver home report.
No, not related to the speed, but in general the overall performance. So, yeah.
So I mean the server link speed, right, is also what you find in kind of TCP dump. So it's our making, the strange number.
Yeah, I think the strange number comes from you're using bonding and the link speed detection doesn't handle that. And regarding the performance, I would bet that's exactly what I meant in my talk, where I would guess the server's just burning CPU and receive message, send message, and so on, and that might be the reason for the poor performance. And if we go to I/O Uring and multiple threads and so on, that should improve.
All right.